Hi guys, today in this session we'll discuss about some concepts of PLC and related concepts to the PLC. So first of all, what do you mean by PLC or Programmable Logic Controller? Programmable Logic Controller is nothing but it is an event driven device, which means that an event taking place in the field that results in an operation. Or you can also define the PLC or Programmable Logical Controller as it is an industrial computer control system that continuously monitors the state of input devices and makes decisions on a custom program, means the program which is written to control the state of the output devices. In this way also you can define the PLC. So after defining PLC programmable logic controller, it has certain advantages, out of which I have the in terms of flexibility, in terms of implementing changes, in terms of the number of contacts, the speed of operation, the cost and the security. First advantage is flexibility. Flexibility in terms of what? If you compare the PLC with the normal convention relay type of device, in case of convention relay type of device, each electrically controlled production machine has used to need its own controller, whereas in case of the PLC, a single machine can control the various applications. So that is very much flexible compared to the conventional relay type of machine. Then second advantage is in terms of implementing changes. So implementing changes means what? If you take in case of again compare with the relay logic panel, the relay logic panel requires more time for the rewiring of the panels and devices in case of the failure, whereas in case of PLC, the program can be changed from a keyboard within a minute. So in terms of implementing changes also, PLC is more advantageous compared to the relay type of machine. Then third one is the number of contacts. So again in terms of the relay logic panel, it takes more times to replace the contacts, but in case of the PLC, you can place any number of contacts very quickly. So that is the third advantage. Then fourth one is the speed of operation. That is, speed of operation means what? Any operation that will be performed by the PLC, it is going to perform at a higher speed compared to the relay based machine. Then fifth one is the cost. Cost means if you take for a more complex function, relay logic panel is costlier compared to the PLC. Then sixth one is the security. Security means what? In terms of the whatever the program you are going to write, it is in terms of the PLC, it is more secure compared to the relay logic panel. Means if you properly unlock this program which you are written, it's very difficult to open that program. Suppose if anybody opens it also, and if you come to know, it can be easily again reprogrammed. So in terms of security also, the PLC is very much advantageous. So these are the certain advantages of PLC. Then as far as it has some advantages, it also has some disadvantages. Like the only disadvantage is it is the having that disadvantage related to the process environment, such as if you continuously operate the PLC device, it may result in a heat, or it may result in a interference with the electronic device, and third one, it also results in the vibration of the devices. Okay, so these are the disadvantages of PLC. Then next we will move on to the very important part of the PLC, that is nothing but the block diagram of PLC. So if you see the block diagram of PLC, it mainly consists of three parts. One is the central processing unit, or what you call it in short as CPU. Second one is the input output module, and third one is the power supply. Then we'll see one by one what is the meaning of those. First one is, as I said, these are three parts. First one is the central processing unit. Central processing unit is nothing but it is going to replace the control relays, timers and sequences which are used in case of your relay based conventional relay based machine. Okay, and CPU has basically three parts. First one is the microprocessor, second one is the memory, and third one is the power supply. So microprocessor is nothing but it may be a 1-bit processor or it may be a word processor. So 1-bit processor is responsible for performing the logical operations, whereas the word processor is responsible for performing the for manipulating the text and other data. Okay, so the microprocessor is responsible for performing the arithmetic and logical operations as well as for manipulating the other data such as text, audio, video, etc. Okay, then second one is the memory. Memory is nothing but it is used for the storing the data as well as retrieving the data. Means memory means it is going to store the what you can say that user data as well as the the system data. Okay, so it is going to use it for storing that data. And third one is the power supply. Power supply is one, it is going to convert the AC supply into the DC supply, and it is going to give you the constant DC supply to the PLC device. Okay, so this is the what I can say that the how we are going to take that is the power supply. Okay, means the CPU is divided into three parts. Then next comes is the input output modules. Okay, so why the input output modules are required is the inputs to the PLC and output from the PLC are necessary to control and monitor a particular process or a particular application. Okay, and how it is done is the input or output device address is identified by its addressing formula. Means each device which you are going to give, it is having its own addressing format. Based on that particular addressing format, the input or output device address is identified. Okay, so this is input output modules. And third one is very important one, that is the programming device. So what is the use of the programming device is, by using the programming device, the user can communicate with the circuit, okay, inside the PLC. Means the programming device allows the user to do the following functions, like it allows the user to enter the program. Also, if necessary, it also allows the user to edit the program, and time to time it allows the monitoring of the program. Okay, and after executing the program, it also allows access to the user memory. Okay, so this is about how the block diagram of a PLC will be there. Okay, next comes is the process scanning of a PLC. How the PLC process can be scanned. So it mainly consists of three processes are there. One is called as input scan, second one is the program scan, and third one is the output scan. So that can be shown by this block diagram. Okay, so it consists of input terminal, input status table, user program, output status table, and output terminal. So what happens in case of the input scan is the contents of through the input terminal from the input terminal are read, and the input status table is updated. Be done in case of the input scan. And in case of the program scan, the data from the input state table is taken into the user program, and user program is executed, and then it will be given to the output status table. Okay, or output status table is updated. And in output scan, the whatever data that will be saved in the output status table will be given to the output terminal. Okay, so this is called as the process scanning of PLC. Then next comes is very important when you compare to the PLC, that is called as the ladder diagram. So ladder diagrams are nothing but these are the specialized schematic symbols that are commonly used for documenting the any industrial control logic system. Any application, if you take, with the help of the ladder diagram, you can document that particular application. Okay, and ladder diagram means it consists of certain parts are there, like it has rails, that is the supply power, and it has the many rings or the horizontal lines, and the right vertical lines are going to represent you the return path. That is, if you see this right vertical lines, those are going to show you the return path. And the ladder diagrams can be read always from right or from top to bottom. You cannot read it from right to left or from bottom to top. You should always read it from left to right and top to bottom. Okay, and it has several control elements, but it will be having, it may have many input elements, but it will be having always only one output element or output coil. Okay, then for a ladder diagram there are various symbols are going to be used. Okay, first one is the contacts. Okay, contacts means there are two types will be there, normally open contacts or normally closed contacts. Okay, normally open contacts will represent a normal value, and closed contact means it is going to represent its opposite value. For example, if I take one value as A, or one symbol if I take it as, or one parameter if I take it as A, it is represented by a normal open contacts. If I want to take the opposite of that, A bar is represented by a normal closed contact. Okay, and the third one is going to represent the special instruction, and output is always represented by a coil, and fifth one is represented by the end ring. Okay, then as I said this only, that is the inputs are represented by normally open and normal closed contact, output is represented by just one symbol. Then what do you mean by contacts are? Contacts are nothing but the power is going to flow through these contacts when they are closed. Okay, then coils represent the relays that are going to be energized whenever the power flows to them. Then you can see also the boxes. Boxes are going to represent the various instructions or functions that are executed whenever power flows to the box. Okay, so various instructions are going to be stored in the boxes. Whenever the power is given to them, the particular instructions are going to be executed. Okay, So this is about the what do you mean by ladder diagram, how it can be drawn. So for our example here we have shown the how the ladder diagram can be shown for the various basic gates. First one is NOT gate. You can see that it is the symbol is shown. Next one is the truth table, that is if A is 0 output Y is 1, if A is 1 output Y is 0. And the ladder diagram is shown by a what, normally closed contact, because it's a the what you can say that A you are giving. Okay, then OR gate. You know that OR gate, the symbol is like A and B are the output and Y is the output, and truth table is like, so whenever when the both the inputs are 0, then only the output is 0. If any one of the input is 1, then output is always 1. Okay, and if you take in terms of ladder diagram, the OR gate is represented by the contacts whenever they are taken in parallel, then that is going to represent the OR gate. Means OR gate, you know that it is going to perform the addition operation. So OR gate or addition operation is represented by the contacts by placing them in parallel. Okay, so A and B are the two contacts which are placed in parallel. So A plus B, whatever operation, whatever the value you give for A and B, the output corresponding to the is represented by the in the coil, that is denoted by Y. Okay, then next one is the AND gate. In AND gate, you know that again A and B are the two inputs, Y as output, and its symbol is shown in the figure. And you know that AND gate is going to perform the multiplication operation. Means when both the inputs are high or when both the inputs are 1, then only the output is 1. If any one of the input is low or 0, the output is always 0. Okay, and if you see the ladder diagram for AND gate, as it performs the multiplication operation, the reverse connection compared to OR gate will be taken. Okay, so in case of the AND gate, the contacts A and B are placed in series. Okay, so whatever value you give for A and B, you are placing it in series. Whatever value you will give, that output is going to appear again across the contact, that is Y. Okay, then NOR gate is nothing but it is the reverse of the OR gate. Okay, whatever you are performing the operation in gate of the NOR gate, that is going to be reverse is performed the their case. So the contacts are also shown, that is with the opposite contacts which are used in case of the OR gate. Okay, and output is represented by Y. And if you see the truth table also, it is reverse of that OR gate. Means whenever both the inputs are low, the output is 1. If any one of the output is high, the output is always 0. Okay, then next one is NAND gate. It is similar to your NOR gate only. Means it represents the opposite state of AND gate. Okay, means what, when both the inputs are high, at that time output is 0. If any one of the input is 0, the output is always high. Okay, so same way you are going to place again in parallel only the A and B contacts, but you are going to use the opposite type of contacts for a NAND gate, and the output is going to be placed across the Y, that is the coil. Okay, then one more logic gate is nothing but the XOR gate. So XOR gate, you know that how it is going to work is, you are going to represent it A XOR B, or the formula for that one is the A into B bar plus B into A bar. Okay, so that is the formula. And truth table how it is going to represent is, whenever both the inputs are same, the output is always 0. If both the inputs are different, the output is 1, or if any one of the input is different, the output is always 1. So you can see the ladder diagram. In first, A is shown as the normally open contact, B is shown as normally closed contact. Okay, so it indicates what, A into B bar, whereas next one is, it is going to show you the below that one is going to show you the A bar into B. So A B bar S plus, because I have taken it in parallel, A B bar plus A bar B is going to show you the XOR gate, that is nothing but the Y. Okay, so that is nothing but you are the output of the XOR gate. Then XNOR gate is nothing but the reverse of that. Okay, compared to the XOR gate. Okay, so if you see the symbol, again A and B are the inputs are there, Y is the output, and truth table is again exactly reverse of the XOR gate. Means if both the inputs are same, then output is always high. If any one of the output is different, the output is 0. Okay, and XOR gate I am going to represent it as, it is represented as A bar B bar plus AB. Okay, so for that reason, in the first line I am representing as A as a close contact, B as also close contact, both are placed in series. So it means what, A bar dot B bar. Then next line I have placed A and B in series, means in parallel, means it is addition. So A bar B bar plus, now here I have placed as a normally open contact, so AB. So A bar B bar plus AB is nothing but the the expression for XNOR gate, and that is represent across the Y output based on the whatever the input condition you are going to give. Okay, then next one comes is the registers. There are the three different types of registers that can be used related to the PLC. So what are those registers are? First one is the input register, second one is the holding register, and third one is the output register. What is the job of these three registers are? First one is input register. Okay, so input register is nothing but it's a 8-bit register. It means what? It's a 8-bit register. It is going to accept the input from 8 different input devices. Okay, so it's a 8-bit register means it is going to accept the input from 8 different input devices, and whenever the input device is on, the corresponding bit of the input register is set to 1. For example, if bit 1, I am going to show it as 1, means the input device which is connected to bit 1 is on, so I am going to show it as 1. And suppose if bit 2, I am showing it as 0, means the input device connected to bit 2 is off. Okay, so if any device which is connected to input register, if it is on, it is represented by 1 in the input register, and if it is not connected or it is not active, means it is represented by 0 in the input register. Okay, then second one is the holding register. Okay, holding register is nothing but it is going to hold the contents of the calculations like it may be arithmetic and logical operations. Okay, and the holding registers are not directly accessible to the inputs and outputs. Okay, so directly you cannot access the input and output. First, the input should be given to the input register. The input register, the contents of input register will be taken by the processor. Processor is going to manipulate the data that is taken from the input register, and then it will be given to the holding register. Again, at the output side also, whatever the data that has been stored in the holding register will be given to the output register, and then from the output register you can take it to the output device. Okay, so this is the job of the holding register. And third one is the output register. Okay, so it is also similar to the output this input only, means whatever the number of bits are there in case of the input register, same number of bits will be there in the output register also. Means at a time how many number of devices you can connect for the input register, same devices can be connected to the output registers also. Means the number of outputs are equal to the number of inputs. Okay, it means what? The output register can give or can deliver the output to the 8 different devices. Okay, and if the output register, if any bit of the output register is set to 0, means the corresponding output device is off. Okay, for example, if bit 3, if it is made as 0, means the device which is connected to that particular bit is off, whereas if bit 0 is 1, means the device connected to bit 1, output device connected to bit 1 is on, or the output register is giving data for bit 0 from the bit 0 to the output device, whereas bit 2, bit 3, it is not giving output error because those devices are off. Okay, so guys, this is about what do you mean by a PLC, what are the advantages and disadvantages of PLC, how will be the block diagram of PLC, then later on what do you mean by a ladder diagram, and what are the contacts will be used, how the ladder diagram can be drawn for various basic gates, then what do you mean by the registers. Okay, so what are the different types of registers that can be used in case of the PLC registers. Okay, so hope everyone, all of you have understood.